Myself, Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri College of Engineering. Today, I'm going to talk about convolution neural network, which is a very important topic as far as image classification and object detections are concerned. And before understanding CNN, we should understand the images. And if you look at the left one, is a digital image, it is RGB image. The center one is a grayscale image, and the third one is the binary image. And RGB image will have three channels. One is red and green and blue. If you look at the grayscale image, the value ranges from 0 to 255. The total number of values are 256, but it ranges from 0 to 255, and for 0 it is black, and for 255 it is a white. In case of binary, we have only 0 and 1. Okay, so if you look at any image, and that consists of many pixels, and each pixel will have intensity color at a particular point. Okay, so that information will enable us to get that will enable us to get the information about the low level features. Okay, I can say. And if you look at this grayscale image, and if you look at the grayscale image here, and the corner ones are going to be 0, and the white ones are around 255. Okay, and if you look at this colored image, it consists of three channels. One is red, green, and blue. And if you look at a point in the image, and that is represented in terms of 255 0 and 255, if it is a case, and you don't have any value in green, and you will have the value of red and blue. Okay, so that is the way it is represented in a colored image. So in the last class we discussed about the multi-layer perceptron, and that neural network, that architecture cannot be used for image and video analysis. So if you look at this tabular column, the ages are one of the feature, and height is also one of the features here, and I can say gender is a label. And if you feed this into the multi-layer perceptron, because we have one hidden layer over here, and age is one feature, and height is another feature. If you feed into this system, you can able to get some output that can be compared with the real one. But if you look at the image that we have seen in the last slide, that consists of many values. Even as low resolution image, I can say it will have many values. For example, I can say if you look at 28 into 3, so this will give you around 2352. Okay, this will give you around 2352. So these many things should be fed into the multi-layer perceptron. So if you fed this information to the multi-layer perceptron, what will happen? You could able to see how many parameters are required, and for the low resolution image itself. Suppose if you go for 200 into 200 or something like that, 200 into 200, you will be able to get around 1 lakh. Around 1,20,000 parameters are required for the required for this kind of architectures. So this cannot be used. This multi-layer perceptron cannot be used for the images and videos. So for that, we have to go for the convolution neural network. What is convolution neural network? It is a mathematical operation is applied on the images to get the important features. And when you apply this in a multi-layer perceptron, and suppose if you look at a grayscale image, and the corner ones are black, so that is as a result you will have 0 values, and the center one is having some white, and it will have some values. So this can be a 7 cross 7, so we will have a 49. It is going to be 49, and if you convert this 2D image into a 1D vector, that is here you will have a 49. So each pixel can be considered as an independent vector. Okay, so independent vector, and it is going fed into the input layer of the multi-layer perceptron. Okay, so what is happening? So, but in actually, if you look at an image, but if you look at a particular pixel, it will have a relationship with the neighboring pixels. Okay, but that is a real that as far as real situation is concerned. But when you convert from 2D to 1D, but each pixel is considered as independent, so it breaks those relationship. So the spatial relationship going to be lost. Okay, we are going to lose the spatial relationship because when you convert from 2D to 1D. Okay, so what is happening when you convert this into this 2D to 1D? You will lose the local information like edges, corners, and textures, and everything is going to lost in the images. As a result, we can't use it. We can't use it in the multi-layer perceptron. We can't use these images in the architecture of multi-layer perceptron. So what we have done was what people have done was, and they try to have a convolution neural network and the way how our human brain works. So if you look at any image and if you look at any object and we look at initially lines and orientations in the low level, and in the next level you look at the simple patterns, and third one is the different parts of the object we look at, and finally we recognize a complex object and faces. So this is a way our human brain works. So this is going to be a low level features. This is low level features, and this is going to be a high level features. Okay. So basically, we try to mimic whatever in a mathematical way. So that is the reason we have different convolution layers, and we have initial convolution layers, intermediate convolution layers, deep convolution layers to capture the different parts of the image, and finally it will be fed with the fully connected layers. Okay, so when we do this kind of operations, and we don't need to depend on more parameters, as we have seen in the multi-layer perceptron. So what is convolution operation? Convolution operation is basically we are applying a filter on the input layer, okay, or input image I can say, and the x1, x2, x3, x4 are the input one, and w1, w2 are the filter or kernel weights. Okay, so when you slide over the input, and we'll get the convolution layer here. Okay, so when you have this x1, x2, x3, then it will be multiplied with w1, w2, w3. Okay, so when you have this, the c1 is basically the multiplication of this, and the multiplication of this, and multiplication of this. Okay, so when you slide one step, okay, and what is happening when you want to have this one, and your x2 will have this, and x3 will have this, and x4 will have this. Okay, so that point we are extracting the features. This is a point we are extracting the feature, usually using the convolution operation. This is for the case of 1D. Okay, we have to do it for this 2D cases for the images. Okay, so what is happening when we don't apply the weights for the each positions? When you don't apply the each position, this is you will have more weightage, more weights you need, more parameters you need. But the same weight is applied all over the places, and you are able to get parameter sharing. So parameter sharing is basically what? It reduces the number of parameters in this case, and it is able to detect the patterns and the hierarchical features from the low level to high level. Okay, so that is the advantage of convolution operations. Okay, so now we will see how CNN network, what is the architecture of CNN network, because if you have a just image and we apply a small filter over here, and we apply a convolution operation, and the activation function here is there's a redo one. When you go for multiple convolution and pulling operations, we are able to get the features. And once you do this, and once you do this, and finally we will go for the flatten the layer, that is 1D operation here. Then it will go to the fully connected neural network to predict what kind of image is it. Okay, for example, if there is any disease over here, and or if there is any it is any mismatch and any obstacles, and we can able to see if it is a normal X-ray, then you will not have any problem. Then it will predict it is a normal, and he has a COVID and everything. Okay, it depends on the image that we have. Okay, so we apply the soft max function over here to predict the classes. Okay, so the fully connected neural layer will have worked for the classification purpose. So both in this CNN we do both feature extraction and classification. Okay, both the things will happen over here. Okay, so we'll see. We will look at what about the 2D convolution, and what is the role of pooling, striding, padding in convolution neural network in the next